Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wonder how your brain learns to fear things it is never actually encountered before? Like what if a certain song is sometimes followed by something bad, and then later just hearing that song puts you on edge? Well, this new study might have a clue. This research is all about how your brain uses its existing knowledge, even memories of safe and boring things, to get ready for danger. It's like your brain is constantly making educated guesses about what might happen next, and it uses everything it's learned, not just the scary stuff, to do that. So the big question here is this. We know Pavlovian conditioning is a big deal. That's the fancy term for learning to associate something neutral, like a sound, with something unpleasant, like a mild shock. Your brain learns that sound means danger is coming. But what happens when there are no familiar warning signs? How do we prepare for threats if we haven't directly experienced them? This is where our existing memories, the ones we build up from everyday life, might come into play. Think about a hiker. They might see some footprints, hear a bird, notice a weird smell. Individually, these things might not mean much, but if they then have a scary encounter, say with a bear, their brain might suddenly connect those seemingly harmless past events to the danger. The claw marks on the tree, even without the bear, might now make the hiker feel uneasy. How does that happen? How does the brain use what it learned in safe times to prepare for danger? That's exactly what this study set out to investigate. The researchers wanted to see if the way we organize our memories of neutral things could actually influence how we react to potential threats. It's like your brain builds a map of the world, not just of dangerous places, but of everything. And when a threat shows up, it checks its map to see what's nearby or what's related to the scary thing, even if those related things were previously just part of a normal day. So, how did they test this? They designed a clever experiment. First, they had participants learn pairs of neutral images. These weren't just random pairs. They were structured in a specific way, like beads on a string forming a line. The key here is that each image was linked to another, and those links created a whole chain or a graph of relationships. Participants learned these pairs over and over, building a mental map of how these images related to each other. They did this for several sessions. Then, the real learning began. The researchers took two images from the very ends of that learned line. Let's call them image A and image Z. They then trained participants to associate one of them, say image A, with a mild electric shock. So image A became a warning signal, a threat cue. The other end, image Z, was associated with safety. Here is where it gets really interesting. After this conditioning, they showed participants the images in the middle of the line, the ones they had only ever seen under safe conditions. They also showed them the threat image and the safety image, and they watched to see how participants reacted. What they found was amazing. Even though these middle images were never directly paired with a shock, people still showed signs of being on alert. And it wasn't just a generic alarm. The closer an image was in their learned mental map to the shock predictive image, the stronger their reaction. Think of it like this. If image A is the threat, and the images are lined up A, B, C, D, E, Z, then participants reacted more to image B than to image C, and more to image C, and more to image C than to image D. Their fear or caution wasn't just about the direct threat, but about how closely related the other images were to it in their learned memory structure. They measured this using what people reported they expected to happen, like, do you expect a shock? And also using physiological signs like skin conductance, that's when your skin gets a bit sweaty due to nervousness, and even pupil dilation, which is when your pupils get bigger when you're engaged or stressed. So what does this all mean? It means your brain is incredibly good at making inferences. It doesn't just learn direct cause and effect. It builds a rich network of how things relate to each other. When a threat appears, your brain uses this network to predict danger, not just from the direct threat cue, but from anything connected to it in its memory map. This is how we can be prepared for novel dangers by leveraging the vast amount of information we've gathered from everyday, safe experiences. This study really highlights how our memories for ordinary events are not just passive storage, they are actively organized into structures that allow us to make inferences. This is super important for survival. It means we can learn from a wider range of experiences than just those directly involving danger. This idea isn't entirely new. Researchers have explored something similar called sensory preconditioning, where learning about one neutral thing can influence how you react to another neutral thing later, especially if they were both linked to something else. This study takes that concept and applies it to threat learning, showing a powerful interaction between our knowledge of safety and our responses to danger. The researchers researchers touch upon brain areas involved, like the hippocampus, which is known for memory formation and navigation, and the orbitofrontal cortex, which helps with decision-making and inference. This suggests a complex interplay of brain systems working together to help us navigate the world safely. It's like the hippocampus builds the detailed map, and the orbitofrontal cortex uses that map to make predictions about potential dangers. One of the really cool aspects is the complementary nature of these memory systems. Pavlovian threat memories, the direct ones, are very strong and tend to stick around. Relational memories of neutral events are more flexible, changing as we learn new things. By combining the durability of threat memories with the flexibility of relational memories, our brains can adapt to new situations and generalize our understanding of danger. This also has implications for understanding anxiety disorders. If our brains are constantly making predictions about threats, and these predictions are based on these learned memory structures, then sometimes these predictions can go awry. In conditions like anxiety, the brain might be overgeneralizing danger based on these relational maps, leading to avoidance behaviors even when there is no real threat. This suggests that treatments might need to address how we structure and interpret our everyday memories, not just how we react to direct fears. Now, no study is perfect, and the researchers are honest about that. They mentioned that it's still a bit unclear if the exact structure of the learned relationships matters more than just knowing there are relationships. They also can't definitively say if the images they used were seen as direct warnings themselves or just as signals for something else that predicts danger. These are excellent questions for future research. But the main takeaway is powerful. Adaptive defense isn't just about direct experience with danger. It is significantly shaped by the maps of the world we build from all our experiences, even the boring ones. Our brains use the structure of these safe memories to infer risk and prepare for threats, even when no familiar warning signs are present. It shows how our cognitive architecture is set up to be prepared, drawing on a broad network of knowledge to keep us safe. So, what's my take on this? I think it's fascinating how this research bridges the gap between everyday learning and our survival instincts. It emphasizes that our memories for neutral events are not just filler. They are crucial active components of our threat detection system. The implications for understanding anxiety and even for developing better therapies are really exciting. By targeting how we form and recall these relational memories, we might be able to tackle problematic avoidance behaviors more effectively. Future research could dive deeper into different types of relational structures and how they specifically influence threat generalization. Imagine if we could train our brains to build better, more accurate threat maps using our everyday experiences. That's all for this episode of RUBIN'S Mind Lab. If you found this interesting, please give this video a thumbs up, leave a comment below with your thoughts. And don't forget to subscribe so you don't miss our next dive into the amazing world of the mind. See you next time.